Hello students, I am Pushkar Rai, Master Teacher in Chemistry at Vedantu. I am going to discuss few problems of JEE Advanced 2020 Chemistry paper. Right now I am discussing paper 1. Students, this question is related to solid state. In solid state, JEE has asked many unusual questions, but this question is not very unusual, pretty straightforward. Only the presentation of this problem is slightly unusual. So let us see what is this problem and how to solve this problem. Is it easy or difficult, or what kind of thinking it requires? According to this problem, the cubic unit cell structure of a compound containing cation M and cation X is shown below, as you can see. When compared to the anion, the cation has a smaller ionic radius. That means cation is smaller and anion is bigger. Choose the correct statement. The empirical formula of the compound is Mx. The cations M and anion X have different coordination geometries. Plenty of facts have been given. So let us first see what kind of unit cell is this and what conclusions we can draw from here. If we see the unit cell, let me draw the unit cell and elaborate it. What kind of unit cell is this? So what is special about this problem is you have never seen unit cell like this before, at least in any book. The way it is represented, you have never seen it before. See, these atoms at these points, atoms are at these points and on the faces. The face atoms are different and these atoms are different. So there are two ways. One is to go about solving, considering it as a unit cell. And if you are slightly confused by this, you can do one more thing. What is unit cell? Anything repetition of which can produce the whole lattice. It is your convenience that what atoms or what group of atoms you are going to take it as a unit cell. So what has been done in this problem is, let me show you. If I extend this cube, and if I take it like this, so by the natural symmetry of the problem, you can see these two atoms should lie here and another atom should lie here. So if you see it carefully, if I join all these lines, suppose I join it by some different colors so that it become more visible. So if you just take this group of atom, you'll quickly recognize that this is a simple cubic unit cell, which you know. This is a simple cubic unit cell. If you repeat this pattern, you will once again get the whole lattice. So the meaning of this statement is, the presentation is that a simple cubic unit packing has been put in different format. So once we recognize this, problem is extremely simple, because now the problem is related to what? The problem is now related to simple cubic unit lattice, and let me show you. So if this is a cube and in this cube all the corner atoms are like negative anions, and in the body center there is a cation. Okay, so that is a simple cubic unit packing. The anions, which is X negative here, and the cation is A here. I have supposed that cation is, this is X and this is anion. So the whole thing has gone. The problem, I'll draw it once again. So this is the cubic unit cell, and there is a cation and the anions are at the corners. Now let us solve this problem. First thing, you will note that the anions here will touch each other. That means if this is the length of the cube, which is A, then the first relation which holds is A is equals to R plus A is equals to twice of R minus, because of course these are anions and they're touching here. Okay, and similarly the cation is touching anion along this body diagonal, which means you have another relationship that R plus R minus twice of this is equals to this body diagonal. And you know that body diagonal is equal to root 3a. So root 3a is equals to twice of R plus R minus, and you already know that a is equals to 2R negative. So if you substitute it here, then we have this expression root 3 into 2 into R negative is equals to twice of R plus R minus. So cancel out this 2 and solve it. You'll get root 3 minus 1 is equal to R plus upon R minus. So let us see. And this comes out to be 0.73. Is there any option? So if we see this, we have one option. The ratio of the ionic radii of the cation M to the anion X is 0.414. So this option stands out to be incorrect. Okay. Now the empirical formula, if you want to check empirical formula, then X negative, how many X negatives are there in this unit cell? These atoms contribute, as you know, 1 by 8, and this atom will contribute 1. So that means you have how many X negative here? You have 1 X negative here, and you have 1 A here. So which means that the formula is AX. The empirical formula is AX. So option 1 is of course correct. Option 1, the empirical formula of the compound is MX, is of course correct. Cation M and cation N have a different coordination geometries. It's impossible, because since the empirical formula is MX, now since the empirical formula is MX, so we can say that MX by symmetry we can easily conclude that the coordination number of M will be equal to coordination number of X by symmetry. If you're not convinced, you will have to see to it. See, this is a cation, and the cation is surrounded by 8 anions. And similarly, if you see the arrangement of any anion, it will also be surrounded by 8 cations. You can easily see this. See, this is the corner of a cube. This cube is present at the same time. This cube is present at the same time. 8 different cubes. That means it is shared by 8 different cubes. In every cube, you will get at the center there is a cation. So which means that this atom is surrounded by 8 atoms. So the coordination number is 8:8. You don't have to really see into it, okay, in 3D structures, because you know if MX, AX, AB kind of compounds, whatever will be the coordination number of A will be the coordination number of B. So that settles the third option. So third option is the ratio of MX. The second option is the cation M and anion X have different coordination geometries. Not possible. So this also is an incorrect option. D option is also incorrect option. Now C option, the ratio of MX bond length to the cubic unit cell. So from this we can get, here we are talking about this length, which is A, and we are talking about this length, which is half of the body diagonal. This length, which is half of the body diagonal. Now half of the body diagonal means what? Root 3a by 2. So we are comparing root 3a by 2 with a. So obviously the ratio is what? Root 3 by 2, which is very close to 0.855 ratio 1. Let's check out what is the ratio here. 0.866. So this option turns out to be correct option. So the correct answer of this question is A and C. So it was total involvement in one single question. They've asked everything, coordination number and ratio of the bond lengths. And the most interesting thing is that this problem is a very simple problem related to a simple cubic lattice. I hope you enjoyed this. Stay tuned for the next problem.